easy. Okay, we're going to go through the vocab as we get through this section, but look at these two first examples. First thing you need to do, get it in slow form, okay? Because if you notice, we're graphing through these. And we're graphing to see what happens. This is our key at the end of the day. You need to know this key. You need to memorize this key, okay? Now, it's fairly straightforward, all right? The graph really tells you everything you need to know, okay? So this one's in slow form?
Yes.
Okay, what about this one?
No.
So we need to add x to both sides, right?
Yes.
We add x to both sides, now it's in slow form, right? So now we're going to graph these out. This first one is -1, up 1 over 1. There's our first line, okay? Got that, right? Okay, second one. Right here, we're going to go to 2. We're going to go up 1 over 1. Now notice, these have the same slope, don't they? Right? They have the same slope, but they have different b's. One's -1 and one's 2. Okay? So after graphing those out, we can see what happened. We're going to focus on this part right here. Okay? Obviously, looking at those lines, we can tell they had the same slope but a different y, right? So that part's easy as far as memorizing. The other part that's easy to memorize is how many solutions they have. What solutions means is crossing the line. If they're parallel, they can never run into each other. So it's none. Okay? Same slopes, different y. The lines are parallel. Now, our lines are parallel, and we call them inconsistent. They're inconsistent of each other. Okay? Are we good so far? Okay, let's go to the second one. Is this one in slow form?
Yes.
Is this one in slow form?
No.
Wait a minute, I got a whole lot going on this side, right?
Yes.
Isn't this one very, very similar to a problem you had on the exam?
Yes.
Yeah. So if this is 0 over here, does this 0 even matter?
No,
No.
it's pretty much nothing.
No, it has no bearing on the problem whatsoever. So really, honestly, the easiest thing to do, we're minus y here, we're just going to add y to both sides, and then we're going to rewrite it. We're going to put y in the front, we know it's 2x, okay? And then we have plus 1. Now it's in slow form, right? So now we can go graph these out. But notice something in the lines. What's going on with these lines?
They're the same.
They're exactly the same. They have the same y, and they have the same slope, right? So we're going to go graph them out. Okay? Plus 1, up 2 over 1, plus 1, up 2 over 1. Then we're going right here. Okay? Same slopes, same y-intercepts. They're consistent, and they're dependent. Now let's talk about that for a minute. Dependent. That's like a kid, right? You have a dependent on a tax return. Why do you have a dependent on a tax return? Ultimately, they're dependent of you providing clothing, food, so they can survive, right? So that's what dependent is, all right? Now, as far as consistent, those lines are consistently the same, okay? So do you understand what inconsistent is then? If you know consistent is exactly the same, inconsistent has to be totally opposite, right? Okay, infinitely many. Let's talk about this for a second. That means every single ordered pair that they connect, they're the same ordered pair, right? So that's a solution. They're touching each other. And these arrows are going on forever. So infinitely many, it never stops. Do we see that? So in this case, this particular line, let's say this was, the x was 1 and the y was 0. It's going to be the same on both lines. So looking at this one, 0, 1. Are they both 0, 1? Yeah, they're both 0, 1, right? 0, 1. X is 1 and y. And then going up, our y being 0 and our x, every single point is exactly the same. Okay? So their solutions go on for forever. This is all you need to remember. When it's the same line, they're exactly the same. They have the same slope, same y-intercept. They're consistent. They're dependent on each other. If they're not on top of each other, it's not the same line, then they'd be independent, right? But these lines are not independent. They're exactly the same. For them to be exactly the same, they're dependent on each other. Infinitely many for the solution. Okay, any questions? So just like you're doing now, you're going to write description. That's describing the line. Classification. Classification is consistent or dependent. Or independent, inconsistent. Okay? And then number of solutions. How many times they cross? How many shared order pairs do they have? Are we good so far? Okay, let's go to the next one. This one in slow form? Is this one in slow form?
Yes.
Yeah, so we're going to go graph these out. So we're positive 2, right? And we're going to go up 1 and over 3. Oh, hold up.
I'm saying it.
Oh yeah, the lines are going backwards. Yeah, the lines are going backwards. Oh, and this one's positive, right? So this one should be 2 up 1 over 3, and this one's down 1 and over 3. So these ones actually aren't going to intersect. So let's I don't know why I did that. Well, let's graph this one out together. Write this out in your notes. Just put a graph. You're going to need 4. If you go 5 points up around, you'll be okay on that one for your notes. So let's talk about this one. I need 2 colors. Let me do red and blue. So both in slope form, right? But what's key is this one right here. So let's do this one first. Let's do this in blue. This one's going to be 4, right? My rise and run is what direction?
Down 1.
Left.
Only time it goes to the right, correct? So
Oh.
down 1 over to the right, there's our line, correct? Let's go ahead and label the line. Okay, now we're going to do the next one. We're 2, right? So our y is 2 and our rise and run is what? Up 1 over 3. So notice, if I go down 1 and over 3, continue these lines actually will be parallel. Because the slopes are opposite of each other, whether one goes down or one goes up, it's still going to cross the axis and go the other direction, right? So this one going down 1 and over 3, it's going to go up 1 over 3, which is the same as this one right here. So actually, these ones are going to be same slopes. I wonder if I put a different problem to change it. So these ones are going to be same slopes, right? They're going to be parallel, inconsistent, and solutions is going to be none. So this table, if you remember, this graph, how many ordered pairs do these lines connect?
1.
1. If the lines cross each other, it's 1. Even if the lines are the slope, let's say the slope was off, it went up 1, it went up 2 over 1 instead of 1. It might connect way up in the graph, but it is going to connect at some point, okay? And if it's connecting up, there's an ordered pair, then this is what you're following, right? They're going to have different slopes, they're consistent and independent, and there's exactly 1. Notice something. Is inconsistent only happens one time, right? It only happens on parallel lines. So if you remember that, you can remember the classifications, right? Look at this. Classifications, inconsistent. Same line, consistent. Crossing, consistent. This one's independent, this one's dependent. Can't be independent or dependent if it's parallel. It's just parallel. That is the description. Okay? Any questions on this? Let's talk about the do now for a second. Is this one in slope form?
Yes. No.
Is it?
Oh, no, I thought you were pointing at.
Nope. Is this one in slope form?
Yeah.
It is. Take these 2 lines, put this one in slope form, graph them out, tell me the description, classification, number of solutions. What about this one right here?
Yes and no.
Isn't this one very similar to this one right here?
Yeah.
+1.
That 0, yeah, that 0 doesn't matter at the end of the day. What about here? What do I need to do here? Yep,
Then,
get the y by itself at the end of the day. Are these 2 ready to go?
yes.
What?
I'll distribute it properly.
Yeah. Yeah, and you definitely need to distribute it. It's not going to change here, but it's definitely going to change there, right? That y-intercept's going to be positive too. Okay, so you want to graph these out. You want to do the description, classification, number of solutions, and then from there, flip over your notes real quick. One more time, the second sheet. There you go. You want to finish that worksheet. Yeah. That table is the same thing. The only thing that's different, if you notice, the graph is on the top. Okay? So that's the same thing. And you want to know that because we're going to spend today, tomorrow, practice problems on Wednesday, and this is our test on Thursday. Okay? Is there anything really new here? No. There really isn't. The only thing that's new is this part right here. Classifying them, right? Describing them, classifying, and tell me how many solutions there are. Okay? Okay, make miracles happen.
There you go.